Hello, my name is Shwetava Ganguly, and I'll be presenting our recent work on conditional generation of synthetic image-like data for geospatial computer vision. In recent years, with the rapid growth in sensors and devices gathering various forms of multimodal and spatiotemporal geospatial data, there has been an explosion in the types, complexity, and size of geospatial datasets. We focus on GPS trajectory data in this work. We first discuss how trajectory data can be transformed into image-like data that is amenable to analysis using computer vision techniques. We then propose a model to synthetically generate such image-like data for targeted data augmentation. In recent work, we have shown that computer vision-based analysis of trajectory datasets can help us build supervised models for geospatial feature detection to build, improve, and maintain mapping applications. For example, semantic segmentation can help detect road center lines, pedestrian crosswalks, traffic control devices, among others. Synthetically generated data can be an inexpensive solution to train supervised models for detecting significant changes in traffic patterns due to infrequent or rare events, for which label collection is expensive in time and money, such as junctions changing to roundabouts, changes in traffic control devices, among others. To motivate this work, consider the case where we have the road network and the real heat map of the superposition of all GPS trajectories at a geographic location for a time duration of delta t. The proposed model can use modified or artificially manipulated road networks as conditional inputs to generate what the traffic would have looked like at this location using information the model has learned from the training data. A supervised change detection model can then be trained with concatenated real and synthetic heat maps as inputs and the difference of real and modified road networks as labels. In order to transform trajectories to an image-like representation, consider the superposition of trajectories within an observation time interval of delta t. Overlay on this a grid of zoom 24 tiles, which have a spatial resolution of 3 meters. Consider an image consisting of 128 cross 128 zoom 24 tiles. In the channel dimension, we add C channels which correspond to semantically meaningful real numbers. Let's look at a concrete example. Consider a location with the road network as shown. A count-based raster map or a CRM is a single channel representation where each grid cell is populated with the number of trajectories passing through that cell. If this number is bucketed based on the heading direction of the GPS records into 12 buckets of 30 degrees, and each bucket is represented as a channel in the image, we obtain the bucketed heading count-based raster map or HCRM. These are the two image-like transformations of trajectory data we will try and generate synthetically. We propose a deep conditional generative model that combines a VAE and a conditional information maximizing GAN and simultaneously conditions on pixel level and feature level inputs to generate synthetic image-like representations of trajectory data. A raster representation of the road network is an example of a pixel level input, while macro level attributes like time duration of observation, GPS noise, season of the year, etc. are feature level inputs. For details of the training methodology, dataset, and loss functions, please check out our publication mentioned below and our poster at BayLearn. Let's jump into some results. Shown here are synthetically generated examples of CRM and HCRM compared with the ground truth using the road network as the only pixel level input. Comparing the accuracy of generated samples from our model with the ground truth in a test set, and from samples generated from other deep conditional generative models like conditional VAEs and conditional GANs, we see that our model outperforms the baselines for both CRM and HCRM generation. Our model can be viewed as incorporating the best of both the conditional VAE and conditional GAN models with some additional modifications. Access to the latent space yields rich dividends. Extending an existing method in literature with some modifications, a linear classifier is trained on the latent representation such that modulating the impact of a binary macro level attribute on the generated sample is as simple as varying a scalar alpha. In the picture, the time duration of observation, or delta t, is the macro level feature that varies as a single scalar alpha is varied. For example, we observed that alpha equal to 0.45 corresponds to doubling the time duration. In conclusion, the VAE-Info-cGAN is a flexible, deep conditional generative model that can synthetically generate good quality samples of semantically meaningful, image-like representations of trajectory data with some limitations. The quality and geospatial diversity of the training data is crucial to model performance, especially when tackling diverse geographies with inherently different characteristics. In the same vein, challenges of data and concept drift need to be explicitly tackled. Please check out our paper referenced below for more details. Thank you for your attention.